Okay, good morning class. So today we're looking at number patterns. You guys had some homework, correct? Okay, the homework was exercise. Exercise 3.3. Did we conclude exercise 3.3? What was your homework, people? 3.3. The alternate sums, so odd numbers. 1 to 10. Any issues here from 1 to 10? Any of these sums you would like me to read you? Or to do on the board? You got all right. Okay. Your homework is going to be out of exercise 3.3 on page 75, you do for me the odd numbers from 11 to 19. That should be suffice. So it's 11, 13, 15, 17 and 19 only. Okay, since you guys are okay with this section of work. Okay, your heading for today is geometric patterns of quadratic sequences. Geometric patterns of quadratic sequences. Okay, can I start? Okay, which page are we reading from? Example, and it's on page 76. Okay. So geometric pattern of quadratic sequences. So here we are told that a number that can be represented as a number of dots in a triangular array is called a triangular numbers. Okay, determine the general term of the sequence generated by the number of dots in any triangle in terms of the stage number. So the stage number is the same as what to us? Stage 1, stage 2, the stage is what to us? Term 1, term 2, term 3 and so on. Not so? So when you are given a geometric pattern where it's in terms of a picture, what I do is I transfer this information to a number sentence, a number sequence. Okay? So because they are determining the number of dots in the first term or in the first stage, how many dots are here? 1. Second stage? 3. Third stage? 6. Next stage? 10 and so on. What would be the next two numbers? Write that down and you write down the next two numbers. Okay, so what would be the next term? 15, then 21. How do we get that? So that is going to give you a difference of 2, then difference of 3, 4, 5, 6, not so. So this gives us 1. So since it has a second common difference, this makes this pattern to be quadratic. So what I want you guys to do is to determine the quadratic number pattern quickly. Can you guys do that? So do that quickly. Okay, you guys finish? Yes? Okay. So what do I write on the side? 2a, yes? Then people, 3a plus b, then a plus b plus c. On the bottom up we work. Okay. So it will be in the form of tn is equal to an squared plus bn plus c. So 2a is equal to 1. So a is equal to 3a, which is a half, plus b is 2. 3 times a half is 1 and a half. 2 minus 1 and a half is half. Okay? And then a plus b plus c is 1. So a is a half, plus b is a half, plus c is equal to 1. What's half plus half? 1. So c is equal to 1 minus 1, which is 0. So therefore the general term is Tn is equal to a half n squared plus a half n plus 0. Don't have to write that in. And of course we test it. We test on term 4. So it's a half times 4 squared plus a half times 4. Gives us 10. And term 4 is 10. Okay. You all okay with that? Any confusion? No? Let's look at exercise 3.4. Exercise 3.4 is on page 77. Okay, so here we are told to write down the number of squares in the first 6 diagrams of the pattern. Number of squares in the first 6 diagrams of the pattern. So how do we do that? So how many squares are in diagram 1? 1. Diagram 2? 4. Diagram 3? 9. Diagram 4? So it will be 16. Diagram 5? 25. Diagram 6? Okay, I'm sure you're all seeing the pattern. How many squares will there be in the end diagram? So in other words, they're asking you to work out the general term. That's all? But how do we move from one term to the next? This is actually 1 square, 2 square, 3 square. You all see that? Who doesn't see that? If you didn't see that, you would have then had to go into the quadratic sequence, the first difference, second difference, and then work out the general term. But since we've seen it, that is simple. So that is going to be Tn is equal to n squared. Let's look at C. Is it possible to have a diagram with 150 squares? Huh? That match this pattern. Let's check. Is Tn equal to 150? So Tn is n squared. So n squared is 150. Square root, don't forget plus minus. Okay, so in this case only plus. The n is natural. So n is going to be the square root of 150. Hmm? You see, since 150 is not a perfect square, I think it's 5 root something. 150, 5 root 6. Oops. Square root 150. 5 root 6. So is that the term in the sequence? No. So Tn it can never be equal to 150. Why? Because n is an element of natural numbers. Okay. Do you all understand? Any confusion? No? Let's look at another one quickly. Alright, I'll give you a chance to do this one. Pause the video at this point. Okay. So here we are told and write down the number of cubes in each of the first 6 towers. So the first 3 is given here. So how many cubes are there in the first one? 1. Then 6. Then 18. Then 15. Then 28. Then 35. 45 is 66. Okay. That's the first 6. No? B. How many cubes will there be in the nth tower? So in other words, we're working out the option for the nth tower. What are we working out? 10, the general term. No? That's number 2 now. So as we move from one term to the next, we added 7, then 9, then plus 5. Okay, yes, my mistake. 5, 9, then 13, 17, 21, then 4, 4. So there's a second common difference. So what type of pattern is this? Quadratic. So what do I write on the side? 2a. Then a plus b. Then a plus b plus c. The bottom up. So it's in the form Tn is equal to a n squared plus. Okay. What do I write on the side? 2a is equal to 4. So a is equal to 3a plus b is equal to 5. So it's going to be 3 times 2 plus b is equal to 5. So b is equal to negative 1. Then we know that a plus b plus c is 1. So a is 2 plus b, which is negative 1, plus c is equal to 1. So c is going to be 0. So therefore, Tn is equal to 2n squared minus. Now of course it's worth testing. This with term 3 is going to be 3 squared is 9, 18, 18 minus 3 is 15. And yes, term 3 is 15. Okay? Just not test on term 1. In number 2c, how many cubes will be needed to build a tower that has 120 layers? So this gives us the first tower is layer 1, second tower is layer 2, and so on. Not so. So in other words, I'm going to work out T120. Not so? T120 is going to be 2 times 120 squared minus 120. So it's 2 times 120 squared minus 120. 8,680. Is that correct? Huh? 86,800 6,680. 8,000. Okay. Any confusion there? No? Okay, we'll do another one. Show this in number 3. Which page are we on? Oops, wrong one. Seven, huh? 77. Page 77. Yes, there's a number 3. So do number 3 quickly. You guys finished with number 3? Still busy? Struggling? You guys struggling with number 3? Huh? Who's struggling with number 3? So I'll give you another 2 minutes with it. You must just calculate the nth term. Not so. And what are we counting? The dots. So how many dots are in the first one? Alright. And in the next one? 12. And then? 22. Then? 25. 35. For those of you who couldn't count the dots, here we go. Hopefully that is the issue. So this is number 3. Okay, so how do I move from one term to the next? Adding 7, then 10, then 30, then 3. So it's quadratic. Why? Because it has second difference. What do I write on the side? 2a, 3a plus b, a plus b plus c. Not so? That's going to be Tn is equal to an squared plus bn plus c. So 2a is equal to 3. Divide by 2, so a is equal to 3 over 2. Not so? Then what? 3a plus b is equal to 7. So it's 3 times 3 over 2 plus b is equal to 7. So b works out to be 9 is 14. 14 minus 7, 7 over 2. 5 over 2. Okay, so it's 2.5. Then a plus b plus c is 5. We've got a, which is 3 over 2, plus b, which is 5 over 2, plus c is 5. Because 8 is 4, so c is 1. Is that correct? Right, so what's my formula? Therefore, Tn is equal to 3 over 2n squared plus 5 over 2n plus. We can test it for term 3. So it's 1.5 times 3 squared plus 2.5 times 3 plus 1. We give an answer of 22. Yes, it is. Which makes that correct. Okay, any other confusion here, people? You will understand. The homework, for homework, is the rest of this exercise, which is number 4, number 5. Okay. It's the remaining sums of this exercise. We'd like you guys to do for tomorrow. Okay. I'll stop the video at this point.